The 4G and the 5G technologies are going to coexist for a long time. And it's vitally important that we facilitate standards-based interoperability between the two systems.
What you need to be able to do is take advantage of that physical network infrastructure, whether it's backhaul, whether it's microwave, whether it's the existing MPLS network, and co-opt it into delivering these new services. And what we're really doing essentially is bringing agility to that existing network by enabling it to be dynamically managed and configured by applications, by services, by whatever needs that bandwidth at whatever point in time.
In fact, in 5G, the good part is that we will reuse a lot of existing networks. We will reuse the pylons, we will reuse the fiber optics. And this is the parts of the networks that are very costly.
Intent-based networking, I'm thinking this term comes from another level of abstraction. So when we say SDN, we talk about more of a device level, right? You make the device, software defined, you make your device virtualized. But intent is more of on the service layer, saying I have an intent. I want, if I say something, it can be automatically implemented. Need that level of translation, need to translate whatever intent to the implementation. That layer wasn't enoughly emphasized, addressed. I'm thinking that's the first layer. And then after you can automatically translate and implement, and then you have to realize you have to constantly getting feedback and know if you really deliver what you promised to deliver. So that sense of monitoring, that sense of assurance, and then make it secure and gets the loop going.
You were talking about the network, you are talking about the graph. I mean, you have to take into account that what you cannot say is that the intent is simply about saying, connect me to my to my daughter and send. No, it's a little bit more. It's build me a network. But build me a network is build my network. And build me my network with 3 nodes, 4 links. This, because you have to know that you're talking about a network. That can imply, extremely complicated environment, but at the end is that you work with a very high level graph, you build it, and whatever happens on the underground or the underlying levels is something that you don't care.
You have to pull information out of things to find out whether they're successful or not, whether they're broken, whether they're failing, or whether they've got issues. And you then use that information to make decisions about what you want to do about it in real time. So if a backhaul link goes down, you now know about it immediately, and you're making a business decision about how to react to that. Do you move users onto a different cell tower? Do you try and use microwave backup? What do you do in that instance? And have that happen immediately.
We always say 5G is going to be heavily use case driven. It'll be catered for various needs of the businesses and end users. We see orchestration as a key of pulling together all of the components that are going to be very software centric, that are going to be distributed and highly flexible.
I think that orchestration will become such table stakes. Eventually it'll just be the norm, and being able to deploy at scale will be a natural thing for us.
Orchestration is important because, or overlooked if you like, to the extent that people think of orchestration today in silos.
Yeah.
So I'm going to orchestrate the optical infrastructure, and then I'm going to orchestrate the MPLS network, and then I'm going to orchestrate the radio part of it. And that's all different groups and all different people. You can't deploy 5G services in that manner because they have to be turned on instantly, and they have to move around the network dynamically depending on load and latency requirements and so on. So orchestration holistically across all of these different domains is the outcome required to deliver a new 5G core.
A lot of the internal processes, technologies and architecture are heavily based on open source. We do have a lot of internal skills that are working on the various components of the technology and the organization. However, we are proactively reaching out to the open source community in order to tap into the much wider developer ecosystem.
Open source can be overlooked in a network perspective because people think about using vendors to go solve problems. It's kind of an obvious statement to make, but when that happens and those vendors provide proprietary solutions, it's very hard for that proprietary vendor with a proprietary solution to make that work with lots of other different vendors who are competing against them. So the role that open source plays, and by extension the role that we play as Lumina, is a kind of Switzerland in this, meaning that we're working with any and everybody in this environment.
If we have some closed solution, it will be difficult to innovate. So that's why we need to have some kind of open network, also to ease newcomers also to use our open platform and so on. So that's why we believe that we need this openness. So on openness means, let's say, open API, but also open source code. Why? Because also we need to automate as much as possible, because we need to deploy a lot of new functions in our network in the future, and there is no way except automation.
If I have to pick something, which is I believe is the fundamental core of what open source is, I would say collaboration, open collaboration. And that's not just within the organization itself. It has to also be external collaboration, being able to work with global players, finding common grounds, finding consensus, building a technology that scales horizontally rather than focusing on developing things internally and coming up with a vertical stack that will have to operate in isolation.
We're using not technologies, but working models that you would call continuous integration, continuous deployment, things that have come from the IT world or the kind of hyperscale world, and are now really important for us as telcos because it allows us to deploy fast. It allows us to be able to update things really simply. Our biggest challenge is, when a supplier comes along and says, "Oh, you need to deploy the next version," it's like, "Ooh, we don't want to do that." But in this world of working, the new version could come every day. Telcos are brilliant at deploying at scale on physical infrastructure. I, mentioned what Openreach are doing with FTTP and what we've done with 5G. We need to learn that process and that capability for much more software-based solutions so that we can deploy at scale.
One of the biggest challenges in the entire transformation, not only the latest, is how to reskill our staff and how to change the culture of the company. Right, so AT&T actually has a very comprehensive program where we are focusing on retraining a very large number of our employees with the equipment, with the new skill sets and the knowledge that they need for the new world.
So our main challenge from moving from a CSP to a DSP is really around the IT architecture. And as IT architecture director, that's really important for me to make sure that I've got the right stack and the right platform to enable our people to work in a really agile way, and also for us to make sure that we collaborate and co-create with external partners to create great offerings in the DSP market.
So 5G is forcing cultural change, essentially, because the IT group have to work with the networking group. The optical group have to work with the MPLS group. And so from that perspective, it's bringing these companies together. From our perspective, however, it isn't just that they're working together. They now have to take on working in different ways. So for example, bringing DevOps to bear across an organization, having continuous integration test cycles for what the network looks like. And we see our customers going through this journey